Hello guys, here we are again. This is 8.1b, I'll call it, because this is the word problems. All right, so we're going to work about 5 examples and we're going to eliminate a couple examples from this page. Okay, here we go. So it says a 7-foot by 3-foot doorway is to be cut into a trapezoid shape. So it's cut into trapezoid shaped wall as shown below. Find the area of the wall with the door cut out. Ooh, cut out. That means I'm taking it away. So that means I'm going to subtract that door out. Okay, so let's go ahead and label this doorway. So this is 3. This is 7. So big picture wise, I need to find the area of the trapezoid. And then I'm going to subtract the doorway out to get our answer. That's the game plan. You will see me do stuff like this a lot. Game plan. Why am I drawing a blank for the word plan? P-L-A-N. Miss Wilson, come on, get with it. Here we go. Okay, so now we need to find the area for each one. So let's start off with the area of the trapezoid. That's going to be 0.5 times the height times B1 plus B2. I'm doing 0.5 instead of divide by 2 just to save in space for this one. So now I plug in my numbers. These are right angles, so therefore this is my height. We'll say this is B1 and this is B2. So my height is 16, and then I have 13 plus 28. So half of 16 is 8, and then I'm going to add 13 plus 28, which is 41. So then to get this area, I'm going to save on space here, and I'm just going to write this answer right here, times 8, enter, which is 328. So now I need to find the area of the rectangle, which is base times height. So that's going to be 3 times 7, which is 21. Now, if you remember our game plan, we said that we subtract these two. So I have 328 minus 21, which gives me 307 feet squared is the area of the wall. Area of wall without door. Okay, next example. It says, Mr. Brinkley has a triangular shaped area for his horses with sides measuring 30 meters, 64 meters, and 87 meters. He would like to enclose this area with a fence. If the fencing comes in 2.5 meter sections, how many sections of fence will he need? Well, since I'm fencing, that means I'm actually finding the perimeter. It says area about enclosing this area, but that could confuse you. Because we're fencing it, we're talking about perimeter. So to find the perimeter of a triangle, so the first thing we have to do is find the perimeter, okay? Which means that we add all sides. So that's going to be 30 plus 64 plus 87. Okay, so we're going to do the 30 plus 64, so that's going to give me 94 plus 87. I know that our calculator can punch all 3 in there, but your brain can't. So therefore, you work it, the problem, as if you weren't using the calculator, okay? Your brain cannot add all three numbers together. You just punch it in one step at a time. Be thankful that you get to use the calculator. So our perimeter is 181. But it doesn't want the perimeter, it wants to know how many sections. And each section is 2.5 meters. So therefore, for step 2, we have to do the perimeter and divide by 2.5 to figure out how many sections there will be. So we're going to have 181 divided by 2.5. Okay, so when I do 181 divided by 2.5, we actually end up with 72.4. Now, here we have to think. If I do 72 sections, am I going to have enough fence? No. I have to go up because I've got to take into consideration, I've got to do that 0.4. So my actual answer is 73 sections. I may have some extra, but I have to do that so that I can make sure I can fence in the entire area. All right, moving right along. We're going to jump down to number 5. Of course, you're going to come back and do 3 and 4. So for 5 and 6, we're looking at this figure right here. So it says plans for a rectangular shaped garden will include a 2-foot wide cement walkway surrounding it, as shown in the picture below. If concrete costs $4.50 per square foot, how much will it cost? So we want to know how much will it cost to fill the walkway. Okay, so we got to figure out what is the dimensions, because this 42 represents from here to here, but I need to know what is the dimensions from here to here. Well, it says this is 2 feet here because it's a 2-foot wide cement walkway surrounding. So it's 2 feet there, 2 feet here, 2 feet here, and 2 feet here. So in a sense, I've got to take away 2 feet on each side, which means this inside right here is going to become 38. Here, this is 26 from here to here, but I need to know from here to here. So again, I'm taking 2 feet away on each side. So that's in a sense subtracting 4. So that's going to make this 22. Now, we're wanting to just fill the walkway. So my game plan is I'm going to do the big minus the small to get the walkway. Okay, so here we go. Let's calculate the big area, which remember is base times height. So that's going to give me 42 times 26. 42 times 26 gives me 52. And now I'm calculating the small, or what you might call the inside. So here's the small. I'm still doing base times height, so, but this is going to be 38 times 22. Oh, I mistyped. 42 times, that doesn't make sense. 42 times 26 is 52. Miss Wilson needs to pay attention to what she's typing. Yes, that number makes a little bit more sense. This is why you pay attention to what you write. This is 1092. So now when I do the 38 times 22, that's 836. And then we said to calculate this, we subtract the 2. So when I subtract, we end up with 256 feet squared is what the walkway is. But hang on. I needed to know that, but it wants to know what the cost is. So I now have to take this, which is the area of the walkway, and I have to multiply it times the cost. So I'm going to be doing 256 times $4.50, which gives me my final answer is $1,152. This is the final answer. So there's multiple steps in these. Okay, here we go. Next example, next page. Of course, the pages do not want to cooperate. Okay, number 7. It says, if Mr. Marsh plans to tile the floor in his 6-foot by 8-foot front hall, if each tile is 8 inches square, so we've got a change in units here. We're going to have to remember that. What is the minimum number of tiles needed to cover the floor? Since we're talking about covering, that means we're dealing with area. Okay? So for this, I've got to find the area of the floor, and then I have to divide out the tiles. So my game plan is the floor area divided by the tile area, but they're different units. So the first thing I've got to do is change these to the smaller unit. So I'm going to change the 6 feet to inches and the 8 feet to inches. So 6 feet, I multiply, so I'm doing 6 times 12, which is going to give me 72 inches, and then I'm doing 8 feet, so I'm doing 8 times 12, which gives me 96 inches. So now when I'm finding the floor area, we're doing base times height, okay? And you assume that it's a rectangle because most areas, or it would have been better if it said a rectangle here, but it's assuming that you know that. So I'm doing 72 times 96. So it gives you that area equals 6,912 inches squared. Now we need to find the tile area. Which is still base times height, but it's a square, so that means I'm doing 8 squared, which is 64. So now, according to our game plan, we're doing the floor area, which is 6,912, divided by the tile area, which is 64, so that to figure out the number of tiles. So we do 6,912 divided by 64, which gives me 100. Numbers are jumping ahead. 108 tiles. Last one. Looking at number 8. It says the total area of a picture frame, total area, including the glass and 1.5 inch wide wooden frame, is 238 square inches. If the frame is 17 inches tall, what are the dimensions of the maximum picture size that will fit in the frame. Okay, maximum picture size that will fit in the frame. So therefore, I'm needing to find it wants a 1.5 wooden frame. Okay, so for this, we're trying to find what are the dimensions inside of here. Okay, remember we've got the frame that's 1.5 here. It's also 1.5 here, and it's also 1.5 here and 1.5 here. So that means that I'm going to go in here some and in here some. Well, if it's 1.5 on each end, that means it's 3 inches off the total. So therefore, this is a 14. Just so we know that part. What we don't know is this distance here or this distance here. But once we find this one, we can find this one. So we're going to take our information, okay? And we're finding the area. We're given the total area. So this is an area of a rectangle. So we have the formula A equals base times height. My total area is 238. We plug in our information that we're given. We know that the height or the base, whichever one you want to call it, the height, I would probably say this is the height, is 17. So I have 17 times the base. You always write the number in front of the variable. And now we solve. So I'm going to divide by 17 on both sides. And I end up with the 14 equaling the base. So that means this right here is 14. So to find the inside amount, I'm going to do 14 minus 1.5 times 2, which is 14 minus 3. So that gives me 11. So therefore, the dimensions of the actual picture, so the pic dimensions are going to be 14 inches by 11 inches. Okay, now we're going to eliminate 2 problems, okay? You are not needing to worry about number 9 and number 10. Skip these. We will learn how to do these at a later date in the next unit. All right, so you're going to finish the notes, and then you'll do the scavenger hunt or whatever homework assignment is given. Have a great day.